This is section 06, matrix operations. The I can statements for this section: I can use characteristics to describe matrices, and I can add, subtract, and multiply matrices by a scalar. So a matrix is a rectangular array of variables or constants in horizontal rows and vertical columns, usually encased in brackets. The elements are each value of the matrix. So when we look at a matrix, it has rows and it has columns. So this matrix A has 3 rows and it has 4 columns. Each number inside of it is an element. Now they can depict the element as, because this is matrix A, it's A sub 24. The first number tells you the row, the second number tells you the column. So you would go down to row 2 over column 4, and A24 is -6. The dimensions are the description of the size of the matrix. A matrix, again, we go by rows and then by columns. So you have m rows and n columns, and our dimension is m by n. So the number of rows by the number of columns. So in this case, this is a 3 by 4 matrix. So if we look at this example, we need to state the dimensions of A. We have 2 rows, and we have 3 columns, so this matrix is a 2 by 3 matrix. Now if we need to find the value of A sub 13, this means row 1, column 3. So if we go to our first row, we go over to our third column, that element has a value of -18. A square matrix is a matrix with the same number of columns and rows. It should look like a square. Equal matrices are 2 matrices that has each of the elements of one matrix equal to each of the elements of the other matrix. And a zero matrix is a matrix in which every element is 0. When you go to add or subtract 2 matrices, they have to have the same dimensions first. If they do not have the same dimensions, it is just not possible. If they do have the same dimensions, then you're going to add the elements that are in the same location or subtract the elements that are in the same location. So A and E are the elements in the same location for those first 2 matrices. So we would just do A plus E, C plus G, B plus F, and D plus H. Do the same concept with subtraction. So if we take a look, we need to find matrix A minus matrix B. Let's go ahead and write this out. So we're going to do matrix A minus matrix B. So in the element A11, we would have A8 minus 12. Then on A12, in the first row, second column, we have 3 minus -7. So 8 minus 12 gives us -4. 3 plus 7, because it's minus a negative, so it turns plus positive, is 10. Then we have -11 and 37. So our solution is just -4, 10, -11, and 37. This time we need to add. If we notice, the dimensions of the first matrix are 2 by 2. The dimensions of the second matrix, it has 2 rows, but it only has 1 column. Since the dimensions of these matrices are not the same, this one is not possible. A scalar is a constant by which a matrix can be multiplied. So it's a number that you're going to multiply by the entire matrix. When you multiply with a matrix, you're going to multiply each individual element by the value of the scalar. So you just need to think you're going to distribute that scalar to each piece inside the matrix itself. So we're going to take this 3 and we're going to distribute it here, here, and here. So 3 times negative 6 gives us negative 18. 3 times 7 is 21. 3 times 10 gives us 30. 3 times negative 3 gives us negative 9. 3 times 2 gives us 6. And 3 times negative 15 is negative 45. Now we can have a scalar multiplied by a sum or a difference. We're going to do the stuff inside the parentheses first. So we are going to add matrix P plus matrix Q, and then we will multiply by the scalar. So the first thing we did was we added the 2 matrices together. Remember, you add the elements. So 2 plus 10 gave us 12. 3 plus negative 7 gives us negative 4. Negative 5 plus 6 gives us 1. And 7 plus negative 2 is 5. Once we have this, we're going to multiply by that scalar of 4. So you're going to distribute the 4 to each piece. So 4 times 12 is 48. 4 times 1 is 4. 4 times negative 4 is negative 16. And 4 times 5 gives us 20. Now we can also have to solve to find the value. So right now we have 4x minus b is equal to a, but we don't know what matrix x is equal to. So if we fill in the information we do know, we want to get the matrix x by itself. So the first thing we can do right now, it's 4x minus matrix b. So we can add matrix b to the other side. So if we add matrix A and matrix B together, negative 9 plus 5 is negative 4. 15 plus negative 7 is 8. 4 plus 8 is 12. 2 plus 14 gives us 16. Negative 10 plus 10 is 0. And negative 5 plus negative 3 is negative 8. Now we still need to get the x by itself. Right now it's 4 times x. So we are going to divide by 4. Or we can write that as we are multiplying by 1/4. So over here this will cancel. So now we're just multiplying by a scalar. And we're left with the x is the matrix of negative 1, 2, 3, 4, 0, and negative 2.